The BeyondTrust platform for privileged access management includes privileged password and session management, secure remote access for the service desk and IT administrators, and cross-platform endpoint privilege management. If you need to discover passwords, secrets, and keys, and manage sessions in which they're used, then Password Safe is the solution you need. It enables auto-discovery of passwords, enhances session management, and offers visibility into how credentials are used. In this demo, we'll focus on how managing credentials with Password Safe improves productivity and security for privileged users and administrators. We'll also show how BeyondTrust records everything for auditing purposes. Most organizations have a high number of privileged accounts. For small organizations, this can be hundreds or thousands of accounts. In large organizations, the number of privileged accounts can be astronomical, and the variety of systems using the accounts grows. Prior to implementing Password Safe, most organizations struggle with three major challenges. First, inconsistent manual processes make it difficult to manage credentials at scale. Some administrators use a personal safe, others an encrypted Excel file, while others may even use a text document on a file share. Second, privileged accounts are often required for scripts and applications to work. These are often embedded as static credentials within these applications and scripts. Unfortunately, embedded accounts are often overlooked by many password management solutions. Finally, these manual, inconsistent processes result in limited visibility into what the privileged accounts are and how privileged accounts are used by users and systems. This lack of automation, coverage, and oversight can result in data breaches, audit failures, and lost productivity for the organization, all of which are costly. BeyondTrust Password Safe solves these problems and more, giving your organization centralized discovery, management, and auditing of privileged accounts. Here's how. First, Password Safe enables automated discovery. This means you can scan your environment, identify assets and accounts, classify them, and then bring them under management based on your business rules. Once privileged accounts are under management, Password Safe enables enhanced session management. While privileged users can still check passwords in and out, we also make it possible for them to check out managed sessions. This eliminates the need to expose passwords to users and also enables session monitoring. In addition to privileged accounts, Password Safe also includes app-to-app password management. This improves security by removing hard-coded passwords from your application or DevOps environments, and then rotating those secrets and keys automatically. SSH keys can also be managed by Password Safe, improving security for your Unix and Linux environments. When it comes to granting users access, you can set adaptive access controls or policies to define who can initiate sessions involving privileged accounts, when they can do so, and what workflows should be in place. Finally, Privileged Threat Analytics gives you complete visibility into how and when privileged accounts are used and who is using them. This comes with built-in anomaly detection, making it easy to spot odd usage even among authorized users. In this demo, we'll cover Password Safe from the perspectives of both the privileged user and the administrator. We'll also show how reporting and auditing capabilities give you complete visibility over privileged accounts. Now let's jump into the product. We'll start off by showing a privileged user's experience. Now by role, this user is a privileged administrator. However, we've set up their actual account as a standard user, so you can see here that they can't even install software. So whenever they need to perform tasks that require privilege, they'll need to log into BeyondTrust Password Safe with their standard account. You can see we integrate with Active Directory, LDAP, or even accounts local to the Password Safe. So both internal and external users can be configured for the system. Although not shown here, we can also incorporate multi-factor authentication while you're logging into the safe. Once logged in, the user will see any accounts they've marked as favorites, as well as the ability to query across all the systems or accounts that they have access to. This is an example of roles-based access control. These query results are limited to just those systems and accounts the user is authorized to check out. To check out an account, we can click the host or system itself, or we can select one-click launch. With our more formalized approach, the user would fill out a form to set when they need access, the duration needed, whether it's access to an SSH session or password, and the reason for accessing this account. We can also integrate with your ticketing system and set up an authorization workflow for just-in-time access to privileges. Alternatively, we can take more of a trust but verify method. We know this user is an administrator, and we want them to access the same accounts they could access before implementing Password Safe. So in those cases, they can use one-click launch to gain access without knowing the password, and we'll record that session. Here again, they can quickly say the reason they need access, and we can still align it with our ticketing system. When they click Open SSH Session, Password Safe will assign a one-time use GUID and launch the user's default SSH client. We'll be prompted for a user ID, which is that one-time use GUID, and that tells the system to log the user onto the server as the root account. In both of these cases, the session and the information submitted are being tracked and audited. By way of example, let's go log in as a user who has far more rights. This user has the ability from within Password Safe to replay past sessions and view active sessions. So, as this user, we can dive into active sessions and see the ongoing session in which the root account for the Lin7 server has been checked out. They can even actively monitor the current session. So normally this would take place on two different computers, but just for the purposes of this demo, you can see that the more privileged administrator, who is in the browser on the right, can see in real time everything that's happening in the SSH session on the left. We're also collecting and indexing logs of the keystrokes. We can query across them if we need. We can even terminate and cancel, terminate or lock the session. That can even take place if the user tries to execute certain commands. For example, they're currently in an SSH session on Lin7, which is where we want them to be, but they do not have the authorization to SSH from here to another server. We can actually see that that's a keystroke violation. And there we have the same controls to lock, terminate, or even cancel and send off email alerts if commands are being typed that aren't within those access policies. Now let's say the user closes the session. They still have it checked out, but in 2 hours, which is the duration requested for this session, Password Safe will rotate that root account password. Or when the user manually checks in the session, Password Safe can rotate the root account password and keys if we're using them. One thing to note, while the user did log on with the root account, it was not a direct log on. Oftentimes organizations will disable SSH for root in their environment. Password Safe uses the concept of a connecting account, which then elevates to root once connected. Now to explore a similar scenario with RDP, we'll navigate over to domain-linked accounts. This is where we can link a personal privileged account to a particular host or hosts. In this case, we're going to check out this privileged personal account against a server named Win2, and we'll do the same one-click launch option. Then we'll click Open RDP Session. You can see in this instance, the user doesn't even have access to their privileged account password. So this is a little different from the SSH session in that the user is given a one-time use .rdp file to download. Once run, it launches an RDP session through a proxy on port 4489 and logs them in on the target host with the privileged account. Because we do allow you to use both your native PuTTY or SSH client for SSH and RDP for Windows, your administrators still get the same admin experience they're accustomed to. And you can see when the user opens PowerShell, they're using that privileged account. And just as before, if we go back into the web interface as the more privileged user and view the active sessions, we can see this RDP session. There's a thumbnail view of the session, and we have those lock, terminate, or terminate and cancel controls here. It's important to note these controls can all be initiated programmatically through an API as well. Let's view that session in real time. Over on the right, you'll see we have keystroke auditing, like we do with SSH. We also have enhanced session auditing that allows you to see all the right clicks and left clicks. All those are indexed and can be queried. Terminate and cancel are pretty standard, and lock, you'll see, will put up a block between the user and their interaction with the session. This is a customizable screen as well. so you can brand that to match your organization. Once we've unlocked the session, she has control over it again. You can see we're able to view the session in real time, and we have a complete audit trail as well. So that's RDP and SSH session management. Now let's take a look at application sessions. This is the concept of giving the user access to a privileged account, but only within the context of certain applications. So the user can log on with a domain admin account and have access to directory users' computers, but they can't get to domains and trusts, or sites and services. To show what that would look like, we'll do one-click launch again. Here we'll check out that application session for 2 hours. Again, we'll get a one-time use.rdp file, but rather than taking us to the desktop, we'll take advantage of Windows Remote App capability, retrieve the privileged credentials from Password Safe, and then just launch the application the user checked out. You can see how this enforces least privilege. The user is not even able to install software on their desktop. However, we can authorize them to create new organizational units within Active Directory. If we minimize the window, you can see the user has access to the application only and nothing else. When they're done with the remote application, they simply close the window, and just as before, we have a session audit trail showing everything that was done within that application session. This can extend out to cloud apps and web UIs as well. So here's an example of managing an Azure AD account. Rather than giving this privileged user full access to the Azure portal, maybe we just want to give them access to the Azure shell. We do this with a web UI checkout. Just as before, we'll hit the remote app server. In this case, we launch the browser, retrieve the privileged account credentials from Password Safe, and then log the user in using these managed account credentials. Note that while these are managed accounts in Azure AD, the same concept can work with any web UI, even if you're just using stored accounts. So even if we're not able to automatically rotate the account for a particular application, you can still store the user account credentials within Password Safe and allow subordinates to check out privileged sessions without knowing the credentials. With web UI sessions, we have that same audit trail showing us what someone did with that Azure AD account within the context of the Azure Cloud Shell. Before we wrap up showing the end-user experience, I want to highlight that the web UI is not the only way to retrieve sessions. You can also use your own SSH or RDP tools. To demonstrate this, we'll use an app called MobaXterm. Our Direct Connect options let you check out privileged sessions through this application interface. If you dig into what this session is doing, you'll notice we specify the .rdp files to be downloaded, the remote host, and port 4489. And then the user ID field and delimiters define what we need access to and on what system. That's one reason we can work with any RDP or SSH client, because it's the user ID field and its delimiters that define the access. To translate this user ID string, it says the standard user, then we have the delimiter, needs access to this admin account, then another delimiter, on this system. So we'll launch that session, hit the proxy, and then authenticate using our unprivileged account password. Note that you could also configure multi-factor authentication at this step. Now Password Safe checks out the session and logs the user in with the privileged account specified. You can see we didn't need to access the web UI at all. Now, if we go back into the admin interface as the more privileged user and view active sessions again, we'll see that this proxied session is in progress. We can also see the live view of this session, and we have the lock, terminate, and cancel options as well. These direct connect sessions work with RDP, SSH, and even with application sessions. The only difference with the application session is that the delimiter is a colon, the application name, and the host. So that's how we would go about checking out RDP, SSH, and application privileged sessions without needing to log on to the web UI. Having shown how privileged users would interact with Password Safe, let's now turn to the administrator view. To begin, we'll log in as an administrator and navigate down to Assets and Devices. Here we can see all of our assets. We can also classify our assets based on operating system, business unit, or however else we may want to classify them. And this doesn't need to be a manual process. We can use any parameter that we've discovered about these hosts to define the classification. This is where we would go to start managing passwords with Password Safe. In order to manage passwords on a system, we need to know what platform the system is. Then we would need a functional account. This is the account that has rights to log onto the computer and rotate passwords. We've got some basic general settings down here, such as default durations, password complexity, and so on. You can in fact set password complexities to whatever you need them to be. In this case, we're working with 26 to 43 characters, and we're allowing most everything, but that can be completely configurable. Next, let's go to the Management tab. Here we see that we're not only rotating passwords for this system on a regular basis, we validate and check them on a scheduled basis. Should we find that the password is incorrect, meaning the one that we have in the database is not the same as what's out there on the target host, we'll reset it on mismatch and alert the owner of the system. We also have decided to change this password after every release. So whenever a password or session has been checked out, or whenever the checkout duration ends, we'll check the old password in and rotate it so that nobody knows what it is anymore. Here are the actual local accounts on the hosts that we're managing. We have the ability to test logons from here to ensure that the passwords are correct. We can manually rotate the password, and we have access to historic passwords. This is helpful if you ever restore a system to a prior date and need to know what that root or local admin password was. So this is one of our managed accounts, meaning we're managing its password. We can view the details and see the default setting we used when the account was onboarded. Any change we make here can override what the default settings are. So if you had 10 accounts you needed to onboard, you can pull them all in the same way. But then if you had one that you needed to change slightly, that's easy to do. But these are the various settings of how this account is being managed. So that's the process of managing a particular system. But how do we get the systems into the grid in the first place? You do have the option of a manual approach where you might enter information. But rather than doing that, Password Safe has an onboarding capability where it can go out and scan all the systems in your environment. This scanning capability is the same type of scanning used to detect vulnerabilities, so it's incredibly thorough. We can run general discovery or advanced discovery scans. You can scan a portion or all of your network, and you can scan one or multiple times on a scheduled basis using the scanning agent. Once a scan happens, the discovered assets will then appear here in the asset grid. We'll also gain information about each asset, such as hardware details, open and accessible ports, the processes that are installed or running, various scheduled tasks, as well as any users, named or otherwise, and which services are active. This is vital for when we do change the privileged account password that's running the service. We also know where to update the logon as properties for those services. We can also see the software that's installed on the host, which can be very helpful for classifying them. And then finally, and probably most critical, we can see who has accounts on this system, what their privileges are, how old the passwords are, and are they being managed. We can of course report on all that information, but better than that, we can take that information we gathered in the scan, classify the hosts, then automatically onboard those systems using smart rules. A smart rule is essentially how we classify those systems and then ultimately perform an action. To give a basic example, let's say all our Linux servers have a system name containing Lin. I can create a template for all Linux servers and onboard them using those settings. And you don't have to use system names. You can add many levels of criteria and subcriteria. For instance, I may classify Windows hosts that are in a Windows Asset Organizational Unit. So this allows us to essentially go out, perform a scan, find new hosts, and onboard those systems automatically. We use the same concept when categorizing or classifying the privileged accounts we find on those hosts. So far, I've scanned a host, I know what accounts are out there, I know what platform it is, and I know how to manage its credentials. But now we have to determine which accounts to manage, and that again is where we can use smart rules to categorize and perform actions across these managed accounts. If we go and take a look at our demo example, this is server-root. In this case, we've set up a rule that takes any managed account found in a scan whose account name equals root and places it into a group. The next step might be to start managing the account settings, using complex password rules, and so on. Now, anytime I find a root account on a scan, Password Safe will start managing it. I don't need to do anything more. I just need to start scanning my environment. We'll bring asset information in based on our rules and begin managing the accounts and passwords. And we don't have to use this managed account field. We can set criteria based on things like assigned attribute, or even a user-assigned attribute, privilege, is it sudo or administrator, and rather than onboarding the system or grouping them, I might decide to send an email alert when new privileged accounts are found. That's just one example of the power you can have with these smart rules. I've also got smart groups, which are dynamic groups of accounts. Password Safe will pull from these to implement roles-based access control. So far, we've demonstrated scanning for privileged accounts, onboarding and categorizing them based on our criteria, and defining rules for how they are managed. Now I need to provide users with access to those privileged accounts, passwords, and/or sessions. To do that, we're going to go into configuration and roles-based access control. This is where we would identify a local group to the appliances, an Active Directory or LDAP group, or even a SailPoint role can be used. In this case, let's dive into this Active Directory group. Here's where we see our users, and as we scroll down here, we can see what permissions or roles they have over assets and managed accounts. I could give them a role over all managed accounts, but instead we're being very granular and only allowing access to those Linux server root accounts as a requester. If we want to put an approval workflow in place, we could set another group of users up as approvers. So anyone in this group will be able to request access to the managed accounts that are bound by this smart rule. We can also go into the access policy and define where and when someone can check out privileges. This particular access policy allows requesters to gain access to that root account session all day, every day of the week, from any IP address range. Furthermore, we demonstrated earlier that the privileged user was able to check out RDP, SSH, and application passwords. Those sessions are recorded, we're logging keystrokes, enhanced session auditing is enabled, and in our examples, everything was auto-approved. You'll note though for these users, if they did want to request a password, a single user approver is required. And there are some additional settings here as well. But that's how we would create an access policy. Link it to a role, which ties together an Active Directory group of users and a dynamic group of privileged accounts. Now let's shift gears again and take a look at the audit trail left behind. There are two aspects we'll view. One is analytics and reporting, the other is session audit trail. With the session audit trail, you have the ability to retrieve and query across all the sessions in Password Safe. Earlier in the demo, we looked at active sessions. We also have the ability to review all past sessions, and that includes all session types. We can replay the session in real time. I can also click any one of these logged actions and jump to that portion of the video. Those are available for SSH, RDP, and application sessions. Now let's head over to the Analytics and Reporting console. This is where we can run reports, view saved reports and dashboards, or even subscribe to reports via email. Here I see this month's password and session activity. The graphs show the user activity, and below is the data that makes up the above graphs. You can also download reports in various formats, save a snapshot, or export the data. We've also got quite a number of report types. You can see we have account-specific reports, view password ages, see the number of accounts, view account deltas based on privilege, and so on. You can also view entitlement reports and see what accounts are being managed. To demonstrate this further, we'll view a common report on session activity. We're able to set up the filters the way we like. Also, note that we apply roles-based access control to reporting as well. So if I'm only authorized to see and report on Linux servers, this would be the only group of assets I can report on. By way of example, we'll look at the current month, select the groups we want to see, as well as the assets. If desired, you can save this view or subscribe and have it emailed regularly. In this case, we're going to just run this as an ad hoc report. So, as we've seen, Password Safe enables auto-discovery of passwords, secrets, and keys, enhances session management, and offers complete visibility into how credentials are used.